Hello kids. So today the chapter which we are going to explore in maths is circle. So we are going to look at the properties of the circle. We are going to look at the circle theorem, and then followed by which we will look how to solve the questions using the circle theorem. So circle basically is a chapter which comes in MYP 4 and MYP 5. In some schools it is taught in MYP 4 and some MYP 5. Definitely I have seen one question in IB 2018 or 17 which came from circle, which was for 5 marks. I think question number 3 was that. And in IGCSE, definitely every time circle questions are asked based on circle theorems. Okay, so let's start. So a circle is something which has a center as O and it has got a radius from the line joining the center of the circle to any point on the circumference. So this is my radius. It can be like this, it can be like this, it can be like this. Okay, so any point it joins, this R is the radius of a circle. So the first thing we have to understand in any circle is the radius. Okay, so you remember in your MYP 2, MYP 3, during construction of a circle, you'd be taking a protector, putting it in the center, taking a width from the scale 2 centimeter and moving it all around and drawing that circle. Correct? We know that the area of the circle is pi r square and the circumference is 2 pi r. Anyhow, that's not a part of that in our. So the first thing now we are going to understand about what is tangent. So tangent is something, a straight line which lies outside the circle, okay, and it touches the circle at only one point. So one tangent will be touching the circle at only one point. So suppose this is the point outside the circle from which I am trying to draw a tangent. So this tangent is a straight line which will always be touching your circle at a single point. Suppose this point is T. Okay. Also, one additional property is that from any point outside the circle, let this point be P. So from any point outside the circle, maximum 2 tangents can be drawn. The one tangent is PT and let the another tangent be PS. Okay. So I'm again repeating it, from any point outside the circle, maximum 2 tangents can be drawn. And the best part is that, see, you know that from inside the circle we cannot draw a tangent. Okay, so definitely it has to be, point has to be outside the circle, and only 2 tangents can be drawn from the same point. Okay, although in a circle you can have infinite number of tangents, but from any point outside the circle. Okay, and when from this point these 2 tangents are drawn, both the tangents are equal in length, which means that PT, the length of the PT is equals to PS. Okay. Similarly, if you say there is another circle and suppose the point this time is here. So from this point also you can maximum draw 2 tangents, 1, 2. Okay. So let it be like R and R1 and R2. So again, from one point outside the circle, maximum 2 tangents can be drawn, and here we can say QR1 is equals to QR2. Okay, so this is the first thing to understand in any circle. What is tangent? So tangent is a straight line which can be drawn outside the circle and it touches the circumference at only one point. Okay, from any point outside the circle, maximum 2 tangents can be drawn and both the tangents will be equal in length. Okay, now we will study about the relationship between the radius and the tangent of a circle. Relationship between tangent and radius of a circle at the same point. Okay, so let us draw a circle. Okay, this is a center. So suppose this is the point P from where I am drawing two tangents. This is the first tangent, it touches here, and this is the second, which it does not cut it. Okay, so when I'm drawing the line, it seems that it has cut the circle, but no, it will just touch the circle at this point. Okay, so let this be T, let this be S. Okay, now we know that PT and PS are the tangent and both are equal in length. So to denote the equality, we just mark with this mark saying that PT and PS are equal. Now this is a center which is at a point O, and we can draw a radius from O to T and O to S. Okay, and we know that OT and OS are also equal. Okay, so what do we know here? That PT is equals to PS, and we also know that OT is equals to OS. Now why OT and OS are equal? Because OT and OS are the radius of a circle. Okay, and PS and PT are the tangents of a circle. So the theorem which we are going to understand here is that the radius and the tangent makes an angle of 90 degree where the point they touch each other. Okay, so the tangent and radius makes an angle of 90 degree. So when I say angle of 90 degree, it means that this angle is nothing but 90 degree. Okay, either you can say this angle or this angle. Both the angles are 90 degree. Okay, so this is the first theorem where we need to understand that the radius and the tangent. You know that tangent is going to touch the circumference of the circle at only one point. And similarly, one radius is going to touch at the same point. Okay, if I'm trying to draw I have to draw that radius which touches the same point at T. In that case, PT and OT are perpendicular to each other. Okay, because the angle between them is 90 degree. Now understand, sometimes you know what they ask on the basis of this question only, they join this line PO. Okay, and then they go and say that prove that triangle POT and POS are congruent triangles. Okay, so you can definitely go and prove that. Okay, you know that PT and PS are equal, so definitely this angle will be equals to this angle. We also know that TO and OS are equal, so this angle will also be equal to this angle, and we know that these two angles are 90 degree. So with that, we can go and we can prove that these two are congruent. Okay, hope this makes sense. Now let us start the theorem, different theorems. So first we'll go with theorem number 1. So theorem number 1 says that the diameter of the circle is the longest chord of the circle. Okay, so the diameter of the circle always subtend an angle of 90 degree at the circumference. Okay, so this is the diameter. AB is the diameter here, and this AB subtend an angle 90 degree at the circumference. So suppose it touches the circumference at point C, then we can conclude that angle C is 90 degree. We can conclude angle C is 90 degree. So we can say that angle ACB is equals to 90 degree. Angle ACB means angle subtended by A and B which meets at C. Okay, so AB is the diameter here. AB is the diameter, which means that not only this, if you try to extend it at this point, but it should be extended from point A and point B. From point A and B, you are subtending an angle at this point. Suppose this point be D at the circumference. Then this angle will also be 90 degree. This angle will also be 90 degree. Okay. So it can be on either side. Suppose you subtend this on this, but it should touch the circumference. Okay. This line should touch the circumference, and this angle is also 90 degree. Okay, so always on any side you can say that the diameter subtend an angle 90 degree at the circumference. This is the first theorem. So you can find many questions based directly on this theorem where they will give a diameter and subtending those diameter a triangle is made which is touching the circumference. Please guys remember the point has to touch the circumference. If the point is not touching the circumference, it will not be a 90 degree. So I'll give you an example here. Suppose this is a circle. This is the diameter AB. The diameter will always pass through the center. Okay. And suppose now we go and we make this angle. Okay. Then do not write this. This is not 90 degree. Please remember guys, this is wrong. This is not 90 degree. Okay. Why? Because this point is not touching the circumference. Okay. Perfect. So I hope you guys understood this theorem 1. Let's go to theorem number 2. So theorem number 2 comes and it says that this is a circle and let's take 2 points on the circumference of the circle. Okay. So we mark the point A and B in such a way that it forms a minor arc. Okay. We know that this is the center of the circle marked at O. Okay. So the theorem says that the angle subtended by the arc AB, now it's not necessary that this is arc AB, it can be a chord AB or it can be an arc. Okay. The angle subtended by the arc AB at the center is twice the angle subtended by the same arc AB at the circumference. Okay. So I'm going to write the theorem here. The angle subtended by the arc AB at the center is twice the angle subtended at the circumference. Okay. What I mean to say here is that if you reread the statement, the angle subtended by the arc AB at the center. So suppose this is the angle which is made by the arc AB at center is twice the angle subtended at the circumference. This is twice than this. Suppose this point is marked as C. It should touch the circumference. And if I say that this angle is X degree, then this will be twice of X degree. Okay. So if I say that AB is an arc and if you draw the point on the opposite side, on the opposite segment, okay, then suppose this is 30 degree, then the angle subtended by the same arc at the center will be 60 degree. Okay. Now it can be an arc or it can be a chord. Okay. So sometimes in figure they can show you a chord. Okay. Or sometimes they can show you arc. So it's both arc and chord. Okay. So you have to make your understanding according to it. Okay. Now this theorem looks very easy right now, but sometimes they complicate the question by giving this diagram. Suppose this is the center. Okay. And this is A, B, center is O, and this is C here. Now understand here, in this is an arc AB which subtend an angle X at the circumference. So if I say if this is X, the angle subtended here, this angle, it will be nothing but 2x degree. Okay. So a lot of people get confused here and they start treating this ABCD, ABCO, which means AOBC, as a cyclic quadrilateral, which is absolutely wrong. Okay. So you have to understand again, you have to start taking this arc AB and you have to make your understanding that this arc AB is making an angle at the circumference and also at the center. And the angle at the center will always be twice the angle made at the circumference. Okay. Do not go and write 2x here. Okay. Understand, if this is x, this will be 2x. This angle, if you want to figure it out, it will be 360 degree minus 2x. If I say angle AOB, in terms of, this is definitely a reflex angle. So if you want to find an obtuse angle here, it will be 360 minus 2x. Okay. So hope theorem 2 makes sense. Similarly, if you see the same condition, I'm going to prove this in this part as well. Okay. Using theorem 1, if I say that, okay, if my AB is the diameter, which from center O, which subtend an angle 180 degree at the circumference, then the same will subtend an angle 90 degree at the circumference. Okay, if it is making an 180 degree at the center, it will mark 90 degree. Just this rule also verifies this, and theorem 1 also verifies this. So hope this is clear, guys. Okay. Now let's come to theorem 3. So remember, we have done 2 theorems. Actually, we have done 3 theorems. Okay. The first one, which we have considered, the tangent and the radius one, that I have not written, and that is why I am right now writing theorem number 3, which is actually theorem number 4. Okay. So now this says that, let me draw a figure of a circle. Now let's mark A and B. Okay. Now AB is an arc, and I am trying to draw a chord here. Okay. Like this. Let's be C. And from the same AB arc, I'm going to draw another chord. Okay. Then my theorem says that the angle subtended by the arc AB on the other side, in fact, on the same side, I means on that side, but both this angle should be on this side only. It should not be that one angle it is making here and one angle it is making here. No, in that case, this theorem will not be okay. Okay, the angle subtended by the arc AB on same side of the circle are equal. So suppose this point be D. So here we can say that, suppose this is an arc AB, then this angle and this angle both are equal. So this is also x degree, this is also x degree. So we can go, and we can write here angle ACB is equals to angle ADB. Okay. So this is theorem number 3, which says that the arc subtends the same angle at the circumference. Okay. And remember theorem number 2, I'll come back to theorem number 2 and I'll show you what I have written here in theorem number 2. We have said that the angle subtended at the center. So if you try to subtend this angle here also, okay, it is at circumference, and it will make again angle x. Okay. So see here, I'll again try to show you here. If I try to extend this part, the straight line, and I connect this. So see, the angle at the center from this arc AB is 2x, then here it will be x. So I can mark here as x. Okay. And now theorem number 3 says that these two are equal, which does make sense. Okay. So see, every theorem is complementing the other theorem. Okay. So here we can come and here we can say this, that angle for this triangle, I can say angle AOB is equals to twice the angle ACB. Correct? This is a C. Make sense? So that was theorem number 2. This is theorem number 3. Okay? Hope it makes clear to everyone. Let's go to theorem number 4. Now, theorem number 4 talks about cyclic quadrilateral. Now see, theorem number 1, 2, 3, 4, you don't have to remember. I mean, it can vary, okay? In some different books, theorem number 1 will be some other thing. Theorem number 4 can be other thing, okay? You just have to understand the concept. What does this theorem say? You don't have to worry about the numbering of theorem, okay? So, cyclic quadrilateral. Now, what is a quadrilateral? Any enclosed figure which consists of 4 sides is a quadrilateral. And what is a cyclic quadrilateral? So, understand, cyclic quadrilateral is drawn inside a circle, okay, and all the 4 corners of the quadrilateral have to touch the circumference. Okay, so cyclic quadrilateral is basically it has to touch. When I say it has to touch, it means that the all four sides of the quadrilateral have to touch the circumference of a circle. Then only it is known as the cyclic quadrilateral. Okay, so if you see in this case, if this is the center, and if I try to draw something like this, maybe a square I am trying to draw, correct? But this is not a cyclic quadrilateral. Understand, guys, this is not a cyclic quadrilateral. Okay, because this part is not touching the circle. Okay, this part is not touching the circle. All the three corners are touching the circle. Okay, so we are okay. So the fourth corner is not touching the circumference of the circle. That is why I say that it is not a cyclic quadrilateral. Okay, so you have to keep these points in mind. Okay, we can clearly see that all these 4 points are touching the circle. So we can say ABCD is a cyclic quadrilateral. Now, if ABCD is a cyclic quadrilateral, in that case, we say that angle A plus angle C is 180 degrees. It means they are supplementary angles, correct? Opposite angle, the sum of the opposite angle is 180 degree, which also comes to the conclusion that angle B plus angle D is equals to 180 degree. Okay, and we know that the sum of all the four sides of a quadrilateral is 180 degree. Please note here, it's not necessary that this quadrilateral is a square, rectangle, parallelogram, trapezium, anything. Okay, it can just be a random quadrilateral. Okay, maybe none of the sides are equal and none of the angles are similar. Okay, all the angles are different. It can be. Okay, but the addition of all angles, this angle plus this angle plus this angle plus this angle, will always be 360 degree. In cyclic quadrilateral, the sum of the opposite angles, it means angle A plus angle C is 180 degree, or angle B plus angle D is 180 degree. Now the point is that I have seen some of the students that they learn this angle A plus angle C is 180 degree. And if the teacher gives A here and C here, they go and write angle A plus angle C is 180 degree. No. See, whatever I am writing here, I am following this figure and then I am writing it. Okay. So you have to understand the concept says that addition of this angle plus this angle. So if this is P, this is Q, then angle P plus angle Q is 180 degree. If this is S, this is S dash, then S dash plus S is equals to 180 degree. Okay, so do not go by the naming convention. This is only for this quadrilateral. Okay, you have to understand the concept. So this is what the cyclic quadrilateral says. Okay, now if you see this cyclic quadrilateral, okay, if I try to extend this DC part, suppose there are some questions like this. Okay, you'll see the DC part is extended. Now what I'm talking that this angle, suppose this angle be P and this angle be Q and this angle be R. So we know that P plus Q is equals to 180 degree. We also know that Q plus R is equals to 180 degree. So what we can say that, okay, P plus Q is 180 degree. Okay, why? Because it's a cyclic quadrilateral and opposite angles in a cyclic quadrilateral, the sum of them are 180 degree. Also one more thing, P and Q are not equal. Okay, please mind it. It can be equal. I'm not denying that fact, but there is no condition where it says that it will be equal. Okay, if it is a square or a rectangle, then it can be equal. Okay, but there is no condition that it has to be equal. Okay, and we know that Q plus R is equals to 180 degree. Okay, why? Because it lies on a straight line. So from there we can say that angle P is equals to angle R. Okay, we can say that this angle and this angle are equal. Okay, so this is one of the great thing you have to understand from here, and it can definitely help you in exams. Okay guys, now we come to theorem number 5. Okay, so theorem number 5 talks about the alternate segments. Okay, I'll try to draw a triangle within a circle. Okay, so let this point be A, let this point be B, let this point be C. Okay. Now understand, if I'm trying to draw a tangent from C, okay, tangent at C, okay, from is the not the right word, tangent at C for this circle where center is anywhere, okay, anywhere at the center, okay. So remember, we say that if this angle is P, okay, and this angle is Q, this angle is R, and this angle is S. So we conclude that angle of P is equals to angle Q. Okay. Mind it, angle P and angle Q will be same, or we can say angle R is equals to angle S. Okay. So angles in the alternate segments are equal. These are the alternate segments. If you see this angle and this angle are in the alternate segments, so they are equal, and here they are equal. Okay, so this is what theorem number 5 says. Mostly I have seen very less question coming based on this theorem. Mainly the first 4 theorems are used. Okay, so remember guys, there are actually 6 theorems. Okay, we have skipped one because we have not named this. Remember the first one which we have said. So that is basically theorem number 1. So now you can name this one as theorem number 6. Theorem number 6. Okay, which talks that the tangent and the radius are 90 degree to each other. Okay, so I'll again revisit quickly. Okay, so that you guys can understand, or you can definitely remind. So this is theorem number 6, which is about that the radius and the tangent at any point on the circumference are perpendicular to each other. We can also say that the diameter makes an angle 90 degree at the circumference. We also know that the arc AB makes an angle at the center which is twice than at the circumference. Okay, and both the angles are made by the same arc. Okay, so here are 3 cases which we have verified it. Okay, you can go back and you can look into this. Theorem number 3 which come, we say that okay, this arc AB makes the same angle at the circumference, but mine on the same side, it cannot be on this side. Okay, so you can even join this. Okay, and you can mark that this chord can also make this one. Okay, so you can either write arc or you can write a chord. Cyclic quadrilateral, you know only that quadrilateral with all the 4 sides of the quadrilateral touching the circumference of the circle is known as a cyclic quadrilateral. Okay, and opposite angles sum up to 180 degree. Okay, so yes, so we have done all this theorems. Let's look at few questions, and theorem number 5 definitely the alternate segment I have just covered. Okay, so we know this. Okay, so these are the theorems. Let's go and see few questions. Okay, I have taken a printout of the questions, so we'll try to do it here. Okay, let's start. So read first question and then we'll start. So in the diagram below, O is the center. It means that this point is O, and A, B, C are the points of the circumference. We can see angle A is 29 degree. Work out the size of angle B. Okay, so 2 things we have to know here. First, that the sum of all these angles is 180 degree. We know that the internal angles, if you add all the internal angles of a triangle, this sums up to 180 degree. Okay, and we know one of the theorem, which is theorem number 1, which I have marked in this video. It says that the diameter makes an angle 90 degree at the circumference. Correct? So this means that this is 90 degree. Okay, right? Theorem number 2. Okay, angle ACB is 90 degree because the theorem says that the diameter marks an angle 90 degree at the circumference. So now we have got 2 angles in a triangle. Okay, the value of 2 angles we have got. Okay, this is 90 degree, this is 29 degree. So to get angle, size of angle B, we clearly say that angle A plus angle B plus angle C, the sum of the angles of a triangle is 180 degree. We know this is 29, this is 90. This is something which we have to find it out. It equals to 180 degree. So angle C is going to be 118 minus, if you add this to it becomes 119 degree. Correct? So angle C is going to come out 61 degree. Okay, I hope I have done the calculation correct. If it's not correct, just go and check with the calculator. Okay, 90 plus 30, 120. 120 means minus 1, 119. If you minus 120, 60, 61. Okay. So the answer is 61 degree. So you can go here, write 61 degree. You get 1 marks. Okay. A, B, C, D are the 3 points on ABC are the 3 points on the circumference of the circle. O is the center of the circle. Angle AOB is 112 degree. Work out the size of angle ACB. Come on. We know this, that this arc is making an angle at the center 112 degree. So we can go and we can say that angle ACB is equals to, this is half of angle AOB. Or we can go and write vice versa, that angle AOB, the angle marked at the center, is twice the angle at the circumference. Okay, now if we take this, okay, we know that if we take this, we have to find angle ACB. So angle ACB is equals to half of, and angle AOB is given as 112 degree, correct? So if you do 112 by 2, so 2 5s are 10, 11 carries 12, to 56 degrees is the answer. Okay, hope this makes sense. Now looking at this figure, we can clearly say that, okay, ABCD is a cyclic quadrilateral. Why? Because all the ABCD is a cyclic quadrilateral. Why ABCD is a cyclic quadrilateral? Because all the 4 sides of the quadrilateral are touching the circle. Okay, now see this, such a nice figure. You can clearly see that, we can clearly feel that none of the angles are equal, correct? None of the sides are equal, correct? So this gives a very promising and prominent concept that a quadrilateral, we are talking only about the quadrilateral, not a specific quadrilateral. Okay, so this shows that it needs not to be a square or a rectangle. Okay, now they are saying that find the size of the angle DAB. So they are working out this angle we have to find. We know that this angle plus this angle, we can go and we can write that angle A plus angle C are, is addition of them is 180 degree. We have to find angle A. Angle C is given as 62 degree, and that sums up to 180 degree. So angle A will be 180 minus 62 degree. So if you do, it comes out 118 degree. Okay. Find size of angle ABC. So now we are trying to find this angle. Okay. Now you know the concept. Okay. So you can pause the video, solve it, and then recheck it. Okay. So I'll go ahead and write angle B plus angle D is equals to 180. Now I am able to write this one only because this is a cyclic quadrilateral. Now angle B, I have to find it out. Angle D is given as 95 degree is equals to 180 degree. So angle B comes out to be 180 minus 95, that's 85 degree. Okay, hope this calculation is correct. Just cross check. Now, third question. A circle with center O has a point ABC on the circumference and angle ABC. Now this is again center. Any line which passes through the center and touching both the sides are touching the circumference. So AB is the diameter. Clearly AB is the diameter. And we know theorem 1 which says the diameter subtend an angle 90 degree at the circumference. So this is 90 degree. Correct? So find angle BAC. So we can quickly go and we can say angle A plus angle B plus angle C is equals to 180 degree. Angle A, we have to figure it out. Angle B is given as 20 degree. Angle C, by theorem we have seen it's 90 degree, which comes out to be the addition of which comes out to be 180 degree. So angle A is equals to 180 minus 110, which comes out to be 70 degree. Okay. Let's go to question number 4. If you look at question number 4, A, B, C, D are the points on the circumference. Find the size of angle ACD. So see, AD is an arc, and from there, both the circumference, both of the angles subtended by this arc are joining the circumference at the same side. So we can clearly say that we know the theorem. We say that theorem number 3. We say that angle ACD is equals to angle ABD, which is equals to 50 degree. So this x is nothing but 50 degree. Okay. Again, simple question just based on theorem, no complexity. Okay, simple theorem as it is. Put it here, you'll get the answer. So the question becomes complex only when there are 2 or 3 different theorems combined and they are made in a single question. Then you have to figure out. Okay, and then there are some more things like vertically opposite angles, alternate angles, adjacent angles. So I'll try to make another video for all these lines. Okay, where you have to understand, where I teach you how to find alternate angles, adjacent angles, corresponding angles, okay, transverse angles. Write down the value of W. Clearly, O is center. This is a diameter. Let's mark the diameter as A, B, and the circumference at C. Clearly, you know angle W is 90 degree. Theorem number 1, the diameter is subtending an angle 90 degree at the center, at the circumference. Sorry, my bad. Okay. Or you can use theorem number 2, so this is 180 degree. So the same thing extended here will be 90. Okay. So 90 degree is the answer. Let's look at the part B. Part B we can clearly see. First, let's name it. Name the quadrilateral ABCD. We can see the quadrilateral is a cyclic quadrilateral. Okay. So ABCD is a cyclic quadrilateral. Okay. The vertex of A, we know that the sum of opposite sum will be 180 degree. Angle B plus angle D is equals to 180 degree. So angle D is going to be 180 minus angle B, which is 116 degree. Guys, please use calculator and find the answer. Okay. Okay, sorry. So write on the value of Y. Okay. So if you see, again, if you want to name it A, B, C, D. From the same arc, two angles are subtended, both at the circumference and both on the same side. So we can clearly say that angle ACB is equals to angle ADB is equals to 52 degree. So Y is equals to 52 degree. Look at this figure. Here we can clearly say that let's mark it PQR this time. Okay, I have been marking ABC every time. So if PQ is an arc, that makes an angle 88 degree at the center. Why? Because in the diagram O is the center. They have not marked it. Okay, but this is the center. Okay, so if this is marking an 88 degree, this will be 44 degree. We know half of it, but we can again go and write an angle POQ is twice the angle of PRQ. Okay, theorem number 2. This is given as 88 is equals to 2 times angle Z. So what is Z? 88 by 2, which comes out to be 44 degree. Okay. Perfect. Now let's take question number 6. PQ, RS are the 4 points on circumference of a circle. PR meets A. So A is the point where these two lines PR and QS are intersecting. They are saying that this angle is 57 degree, this is 78 degree. I have to find the value of X and Y. Where is X? I don't know. I cannot see X. Okay. No, you have to just find the value of Y. Okay, angle Y. So this angle. So again, see, this is not that difficult. This is 78 degree, so this will also be 78 degree. Understand? I have to go and I have to say that angle QAP is equals to angle RAS. Why? Because they are vertically opposite angles, which means this is 78 degree, this is also 78 degree. Okay. Now if this is 78 degree, mark this angle as X. And I know that in triangle ARS, the sum of all these three angles should be 180 degree, which means that 78 plus 57 plus X is equals to 180 degree. So from here you can go and you can find X. Okay, so I have to use my calculator. I have to use my calculator. Okay. So what I'm going to do? I'm going to do 180 minus 78 minus 57. That comes out to be 45. So X is nothing but 45 degree. Now I have figured out X. I have to find this. Now see here, QR is an arc. QR is an arc which is subtending an angle at S and also at P. So remember theorem number 3 that an arc subtending an equal angle at the circumference of the circle and both are on the same side, which means that angle X and angle Y will be equal, which makes that angle Y will always be equal, will also be equals to 45. Make sense? Now let's see question number 7. Here they are saying that the diagram shows DEFG, and EG is the diameter. This is the kite. They are saying is the kite. In kite, we know the properties is that this side ED and EF are equal and DG and FG are equal. So I can mark it like this. Okay, we know that these are the properties of kite. Okay, that alternate the adjacent angles. Okay, on this part and this part they are equal. Now we also know that this is 65 degree. This is also 65 degree. Okay, because that's the property, and if this is X, this is also X. Okay, now we know that this is also making a cyclic quadrilateral. So in that case, I can go and I can write that angle E plus angle G is equals to 180 degree. Why? Because all the 4 points are touching the circumference of the circle. We know the angle E will be 65 plus 65, which is 130 degree, plus angle G is equals to 180 degree. So angle G comes out to be 180 minus 130, which is 50 degree. But angle G is actually 2x, and you have to find x. So 2x is equals to 50 degrees, so x comes out to be 25 degrees. So the answer is 25 degrees. Okay. So hope it makes sense, beta. Okay, these are the few questions which we have done. Okay, there are a few more questions. Okay, which definitely you can see this. You can try to solve it. Okay, if you have any doubts, you have my number. It's displayed there. You can text me, you can WhatsApp me, and you can ask the solution. Okay, I'll send it to you. Thank you guys. Thank you so much. Bye bye.